In our modern world, crude oil is everywhere. It helps make the fuel for cars, buses, planes, and ships. It helps produce plastics, packaging, synthetic materials, chemicals, and even the asphalt beneath many roads. But have you ever stopped and asked, what exactly is crude oil? Where did it come from? How do we get it from deep underground? And how can one thick black liquid be turned into so many useful products? Let's dive in. Crude oil is a naturally occurring fossil fuel. It formed over millions of years from the remains of tiny marine organisms. When these organisms died, their remains sank to the bottom of ancient seas. Over time, layer upon layer of sediment piled on top. As pressure increased and heat from the earth acted on the organic matter, it slowly changed into a complex mixture of hydrocarbons. This happened where there was very little oxygen. Without it, the material did not fully decay, becoming crude oil and natural gas. Crude oil is not a single chemical. It is a mixture of many different substances, most of them called hydrocarbons. Hydrocarbons are molecules made only from hydrogen and carbon. Some are small and light, others are long, heavy, and sticky. Because crude oil contains such a wide range of hydrocarbons, it can be separated into many useful parts for industry. Oil isn't usually in an underground lake. It is found trapped in tiny spaces inside reservoir rocks, beneath impermeable layers. Before drilling, geologists study the ground carefully. They use surveys, rock data, and seismic methods to find where oil is trapped. Once a likely reservoir is found, a well is drilled. This can happen on land or offshore beneath the sea. Huge drilling rigs bore deep into the earth until they reach the oil-bearing rock, then crude oil is brought to the surface. Sometimes it rises due to pressure. Other times, pumps are used. Remember, wells extract oil, but refineries process it. Crude oil in its raw form isn't very useful. You can't just pour it into a car engine. It must be separated into fractions. Each fraction contains hydrocarbons with similar sizes and boiling points. This process is called fractional distillation. Think of it like this. If you heat two liquids, the one with the lower boiling point evaporates first and can be collected. In a refinery, crude oil is first heated in a furnace until it vaporizes. This hot mixture enters a tall fractionating column. The column is hot at the bottom and cooler at the top. As vapors rise, different hydrocarbons condense at different heights. This allows the crude oil to separate. Let's look at the main fractions you should know. At the top are the lightest refinery gases like propane and butane used for heating and cooking as LPG. Next is gasoline or petrol. This light, volatile fraction is the main fuel for cars because it burns readily. Naphtha is extremely important. It's used as a raw material in the petrochemical industry to make chemicals and plastics. Below that comes kerosene, commonly used as jet fuel. It's heavier than petrol, but still flows and burns well. Then comes diesel, used in buses, trucks, generators, and many heavy-duty engines. Lower down is fuel oil, a heavy fraction used in ships and large industrial burners. At the very bottom is bitumen. Thick, sticky, and viscous, it's used for road surfacing and roofing. Shorter hydrocarbon chains have lower boiling points and rise higher. Longer chains have higher boiling points and condense lower down. As molecules get larger, their properties change. The larger the molecule, the higher its boiling point. The larger the molecule, the more viscous it becomes. It gets thicker and flows less easily. Smaller molecules ignite easily, while larger ones are less flammable and darker in color. Refineries don't stop there. Society needs more petrol than crude oil naturally provides, so we use cracking. Cracking breaks large hydrocarbon molecules into smaller, more useful ones like those needed for petrol. It also produces alkenes, essential for the chemical industry to make plastics like ethene. In catalytic cracking, heavy vapors pass over a hot catalyst at several hundred degrees to efficiently break them down. This is how naphtha becomes the polymers that form our bottles, containers, and fabrics. Crude oil changed human history. It powered transport, industry, and the entire modern chemical world. But there's a downside. It's non-renewable, and burning it releases CO2, contributing to climate change. Oil spills damage ecosystems, and plastic waste persists in our environment for a very long time. So should we stop? It's not simple, but we are working on cleaner energy and sustainable materials for the future. To sum up, oil formed over millions of years is extracted by wells and separated in refineries. It gives us fuels, chemicals, and plastics. Cracking then helps us meet the high demand for smaller molecules. So what do you think? Should we reduce our dependence on crude oil as quickly as possible? Tell us in the comments and subscribe to Learn with Adeesha for more science.